the fastest spacecraft ever to leave the Earth. A 9-year marathon crossing 3 billion miles to see a mysterious world lurking in deep space.
Is it alive or is it completely frozen?
They have only one shot to get it right.
So there'll be a little bit of tension in the air.
Through unknown peril.
If New Horizons were to hit something as small as a grain of rice, it would be game over.
History will be made, and we are there.
We've hit the mother lode of fascinating objects in this particular mission.
Our destination is Pluto and the Kuiper Belt beyond. This Atlas V rocket is about to launch a very special mission.
3, 2, 1. We have ignition and liftoff.
This is the New Horizons spacecraft. It's on a voyage to the last unexplored planet in our solar system, Pluto. But nearly 2/3 of its journey is in a state of suspended animation. All instruments not essential to navigation and flight control are turned off. This preserves the battery and reduces wear on equipment. New Horizons has had 18 naps since its launch, each ranging from 36 to 202 days long. That's roughly 2 in-flight naps per year. During each nap, the spacecraft sends a beacon tone once a week to let its friends back on Earth know that all's well. But this is the last nap New Horizons will take before it makes history.
We really have never been to a planet like Pluto before. It is the farthest footfall that any humans have ever made on another shore to go and explore a small planet 3 billion miles from Earth.
It's an incredibly pristine body in the sense that it's experienced relatively little evolution over the 4.5 billion years that the solar system has been in existence.
It is a geologic time capsule.
Pluto happens to be a linchpin for understanding the formation of our solar system, and some of the most important questions that we can ask as 21st century planetary astronomers have to do with how the Pluto system formed.
A clue might be found in Pluto's oversized moon, Charon, about the size of the state of Texas and roughly 10% the mass of Pluto itself. Its sheer size suggests something about the formation of Pluto, something terrifying and violent.
The best models we have so far indicate that Charon was formed in a titanic collision between Pluto and another formerly existent planet that smashed into it billions of years ago and spalled material into orbit that coalesced to form Charon and probably the other satellites as well.
Pluto marks the inner boundary of a vast realm at the edge of our solar system, populated by chunks of ice and rock. Some are as large as Pluto itself.
So it's most probable that these icy planets, like Pluto, are actually objects that formed in the outer solar system in great numbers, most of which are gone today for one reason or another. And the ones that we see are the relics of what was formerly a much larger population.
New Horizons is mankind's first reconnaissance of this outer region of our solar system. Pluto is the probe's first destination. We are roughly 4.5 months away.
When we pass through the Pluto system, we're going to be going very deep. We're going to get in closer than any of the satellites orbit. In fact, we're going to pass about halfway between where Charon orbits, the innermost moon, and where Pluto is. So we're going to be way down among them and taking great data the whole way.
New Horizons has a long to-do list, but its goals are simple. Reveal the geology and landforms of Pluto and Charon. map the surface composition, and analyze the atmosphere and determine its escape rate.
What kinds of geological features are on the surface? Is it alive in terms of eruptions or tectonism or volcanism or who knows what? Or is it completely shut down and frozen?
Ever since its discovery, Pluto has been a place of mystery. In 1929, a Kansas farm boy with a talent for building homemade telescopes starts a new job at the Lowell Observatory near Flagstaff, Arizona. That farm boy is Clyde Tombaugh, and his task is to help locate a hypothetical planet thought to exist beyond the orbit of Neptune. He uses a machine called a blink comparator. This lets a person compare images taken on 2 different evenings. Any object that has changed its location won't be a star. It will be a planet. In 1930, Tombaugh discovers Planet X. And at the suggestion of an 11-year-old English girl, Venetia Fair Burney, Planet X is given a new name in honor of the Roman god of the underworld, Pluto. For the next 75 years, Pluto is classified as the 9th planet. Finally, in 2006, the New Horizons mission is launched. But a strange controversy begins just 6 months after launch. For many, it challenges our notion of just what a planet actually is.
And this gets into the whole debate of whether Pluto is a planet or not. Pluto has been labeled a dwarf planet.
In 2006, Pluto is recategorized, in the eyes of some, demoted. A controversy is born.
Well, people ask me all the time about this controversy, and the first thing that I tell them is that it was really started by people who are non-experts in the field.
Most people think astronomers and planetary scientists are in the same line of work. That's only true in the same sense that a dentist and a brain surgeon are both doctors.
Really, most astronomers don't know very much about planets. They're not experts in it. They don't go to the technical meetings. And so the controversy was started by non-experts in the field who happened to get the microphone.
I think an object should be classified as a planet based upon its intrinsic properties, not where it is. Pluto was demoted from planethood because of where it is. Its orbit intersects the orbit of Neptune. And according to the IAU definition, a planet has to have swept out its orbit of debris. And since it hasn't removed Neptune from its orbit, it's not a planet. But by that definition, if you took the Earth and substituted the Earth for Pluto, the Earth would not be a planet. So that's telling you there's something wrong with that definition.
What fuels the controversy even further is the growing number of planet-sized bodies beyond Pluto. At least one is bigger than Pluto. Is it a planet too?
We thought there were only 9, but the final answer is probably closer to 900.
900 planets in our solar system. But the debate about Pluto's status is a double-edged sword.
In some respects, it's very helpful because it attracts people's interest to astronomy and to planetary science by wondering for themselves, is Pluto a planet? By their own criteria. But the other side of that sword is it is very unfortunate what happened in Prague in 2006 in that meeting of the astronomers, because they took a vote.
The recommendation is that we consider Pluto to be in a special class.
More than 2,500 astronomers attend that fateful meeting of the International Astronomical Union. Yet by the time the vote was taken, most had already left. Less than 17% of the attendees were on hand to vote. The problem is that the voting should never have occurred in the first place.
Those who are in favor of Resolution 6A, which introduces this new category of trans-Neptunian objects with Pluto as a prototype.
Votes don't work very well in science because for many people, I think it convinced them that science is arbitrary.
Those abstaining?
That things like, let's say, evolution or global climate change are arbitrary and are decided by voting instead of by data.
237 in favor, 157 opposed.
It should never have done it. I think it set science back. It may have been the worst pedagogical moment for science in recent memory in past decades.
It's hard to imagine that the exploration of a planet at the far end of our solar system can create such turmoil here on Earth. New Horizons is already on its final approach. A lot has changed since that fiery liftoff 9 years ago. Then, there is the discovery of Pluto's moonlets and the realization that Pluto may be surrounded by uncharted shoals. In fact, Pluto is now dead ahead. For the first time in history, Pluto is no longer a dot. April 9th, onboard cameras captured the first color image ever made of the Pluto system by a spacecraft on approach. Even at this distance, distinct differences can be seen. Images taken by LORRI early to mid-April from within 70 million miles already reveal broad surface markings. LORRI uses less power than a string of Christmas lights, yet captures images in black and white. Ralph is a color imaging camera that is able to capture images in light levels 1,000 times lower than on Earth, allowing it to map the night side of Pluto. Ralph can also see in the infrared, the same as night vision goggles. This allows it to see heat sources. And as a spectroscope, Ralph can discover what the surface is made of. But 2 more instruments will let us sniff around and even get a taste. Pepsi will serve as our extended nose, sniffing the air. SWAP looks at the way solar rays interact with the atmosphere.
About 10 weeks before we get to Pluto, we can beat Hubble resolution, and all the way in do better and better, which helps us turn this encounter from a simple weekend at Pluto into a long study of the Pluto system.
Before New Horizons, our best views came from Hubble images, processed by Mark Buoy. As the spacecraft crosses nearly 1 million miles a day, it gets closer, so the pictures of Pluto get clearer. What's revealed are different light and dark regions caused by variations in the planet's albedo.
Albedo just means that's how reflective the surface is. And there's some interesting patterns you see on here. We see this big dark region here, which we've known about for a long time.
These are regions where the ground is covered with some carbon-rich material that reflects very little light.
We've got this region here, which turns out to be the brightest region on the planet. And we also know that's where the concentration of carbon monoxide ice on the surface of Pluto is. Because Pluto's brightness varies as it rotates, we know that there's bright and dark patches on the surface.
Buoy guided mission planners toward a trajectory that coincides with the large bright patch. This series of 3 images was made by the LORRI telescope. Every day, the images get a little sharper. In the coming weeks, LORRI's images are going to improve dramatically. History is being made. New Horizons is 60 million kilometers from target and closing. All systems are working. Sending a probe on a decade-long flight some 3 billion miles away is a crowning achievement of the space age.
It began in the 1950s, and through the advance of technology, we've been able to open up the solar system for the first time. And as Carl Sagan said, it's only true for 1 or 2 generations that you can be the first to Mars, the first to Venus, the first to explore all these places that had just been points of light in the sky, and they become real worlds.
But no new planet has been visited since Voyager 2 passed Neptune. And yet, one world remains tucked away in the pages of history. As New Horizons closes in, a new discovery is made, a discovery that points to sudden danger.
When we discovered Pluto's small moons, we realized that just like every other object in the solar system, they would get struck by still smaller debris as Pluto draws the system through the Kuiper Belt. And that the process of crater formation on those small moons was a little different than in some other situations where we've gone exploring before. Because the moons are so small, they have almost no gravity. And so when you make a crater, all the stuff that comes out of the hole can't fall back on the moon. It's moving too fast for the moon's gravity to retain it. So that debris actually gets into orbit around Pluto, where it's too small to see, but where it poses a hazard to New Horizons, or a potential hazard at least, because the spacecraft is moving so fast to be hit by a rock, or even a pebble, or even something the size of a grain of long rice could be very damaging. So that was our concern.
Here's this grain of rice. This is actually bigger than you need in order to wipe out the spacecraft. In fact, you know, if I I just broke off most of it. Can you still see that tiny little piece there? This is still bigger than what it would take to destroy the spacecraft. Okay, that's a tiny little thing. This is something that was going to break a wire or break a lens or wipe out the computer chip, the CPU, something like that, that's going to be enough to end the mission.
A hazard team is formed. Its goal is to search for any rubble in the flight path. The danger lies in the unseen, whether it's the size of a car or even a grain of sand. New Horizons is speeding in at over 1.2 million kilometers per day. Strike something at this speed, and it's game over. One consequence could be that a damaged spacecraft would keep collecting data, but is now unable to relay it back to Earth. Or the spacecraft loses all of its power and goes cold. Despite the risk, the prospects for a safe passage through the Pluto system look good.
So the odds are very much in our favor. And I don't want to give you the impression that we're, sending it willy-nilly onto the beaches of Normandy, where the kill rates are very high. There's almost no chance that it could be hurt, but there's a small chance because we are flying into the unknown.
Are there regions where the risks of collision are greater than others in and around the Pluto system?
Charon is basically this big vacuum cleaner that's sucking up all this dust around its orbit. That is probably one of the most dangerous places you can go because you could have dust all over out there.
Because of Charon, the safest trajectory is right through the heart of the Pluto system. But the team remains vigilant.
If we find something that screams out, danger, danger, then we can do what's called this antenna to ram maneuver. We'll rotate the spacecraft to put the antenna pointed in the direction of motion for extra protection, just to get it through that bad time. Nobody wants to do that because it does compromise the science we do, but if that means the difference between losing the mission and getting something, that we've got that in our back pocket.
For many, the next few days will be tense.
It might be off most people's regular schedules.
And then it happened. Contact with New Horizons is lost. Mission controllers at the Applied Physics Lab scramble to diagnose the problem. Could New Horizons have struck something in space?
I think I was in the control center between 6 and 7 minutes after I got the call in my office. I'd be kidding you if I didn't say that until we reestablished contact, practically anything could have been the problem.
Some 90 minutes pass. Finally, a telemetry signal is detected, but it is not from the main computer. The team is uploading flyby instructions at the same time that the main computer is compressing data. The primary computer overloads and shuts down. The backup computer is running all systems and directs the spacecraft into safe mode. The bad news is that some data is lost.
We lost 16 Florey imager observations, 4 Ralph color observations. It's about 30 observations altogether over this period of time. We can say that there's 0 impact to the highest priority science.
It takes 2 days to bring the main computer back online. And now the team is back in action.
New Horizons is doing great. It's right on course, and all the scientific instruments are performing completely as expected, and we're getting great data.
After a journey of 9.5 years, 5 days until flyby, New Horizons is arriving at its destination.
And in fact, we're getting a lot of science now, and we're discovering things every few hours. The primary period, the really intensive exploration, is a 9-day flight plan that began on July the 7th and ends on the 15th. Throughout that period, the spacecraft is running as hard a race as it possibly can to get through all those observations.
Status of the spacecraft right now is great. It's operating and doing exactly what we want it to do.
A set of pre-programmed commands will tell the spacecraft which instruments to use and what maneuvers to make during the closest approach. And the latest pictures are dazzling.
Today, for the first time, I'm now looking at this thing, and it's not sort of like a better version of my map, but now a picture of a world. To me, in my head, that transition just happened today. Wow, what's going on there? Finally, we're getting to rule out certain ideas and theories. You know, it's not some big monstrous planet-wide crater, you know, like think of the Imbrium Basin on the moon. That's not what's going on Pluto. But what is, I don't know, but it's an incredible ride just watching this stuff come in day by day.
Another surprise is Sharon's polar cap.
We're seeing a feature on Charon already, which is a dark north polar region. There were no hints of this in the data that I've taken over the past decades.
Charon has a dark pole that was completely unexpected and which we don't understand. But in the coming days, we're going to be able to collect compositional information about it that may shed some clues on what it is. But the details of things like whether there's cantaloupe terrain on Pluto, we'll only know after tomorrow's flyby. So let me describe the encounter, what's going to be happening tomorrow on the 14th. Later this evening, we're going to receive the last signals from the spacecraft, and that's part of the flight plan, because after that point, we're so close to Pluto that we don't want to spend any time turning the antenna back to the Earth to communicate with the Earth, because whenever the antenna is pointed at the Earth, the cameras and spectrometers can't be pointed at Pluto and its moons. So for the next roughly 24 hours, the spacecraft will be completely on its own and very busy, because it's going to conduct hundreds of scientific observations spread among the 6 targets in the system, the planet and the 5 moons.
Now on final approach to Pluto, the probe becomes autonomous, continuously monitoring all of its navigation and science subsystems, its temperature, and its voltages, compressing and archiving data, and tracking the planet. Back on Earth, a huge crowd gathers at Mission Control, anxiously awaiting the moment of closest approach, when the spacecraft, after a journey of 3 billion miles, will be only 7,700 miles above Pluto's surface.
2, 1, New Horizons and Pluto 2015!
New Horizons sweeps past the planet, but it still has work to do.
And then it will start to recede from Pluto on the far side, and continue to make scientific observations throughout the day, throughout the evening. It will only take one break to communicate back to the Earth for about 20 minutes with not data, but engineering telemetry to tell us it made it, it's healthy, give us temperatures, voltages, computer readings, things like that, so that we know that we can feel relaxed about it. That's going to happen on the spacecraft at about 4:30 in the afternoon Eastern Time. But the signal traveling at the speed of light will take 4.5 hours and it will reach the ground around 9 o'clock Eastern Time.
I will breathe much easier tonight at 9:02 p.m. because we've spent so much time studying the hazard, and knowing that the spacecraft has sent us a signal that says it's okay, that just means, okay, the fun begins now. We don't have to worry about hazards anymore. But we'll know that at 9 o'clock. It'll be a great moment.
Now, during that time when it's not talking to us, we believe that the chance of the spacecraft striking anything is very low, around 1 in 5,000, maybe 1 in 10,000. So we think it's very safe. But, you know, that's our baby. And during that time, you wouldn't be human if you weren't a little bit interested in that 9 o'clock transmission to see that everything's going to be all right. So there'll be a little bit of tension in the air. That's only normal.
And on this mission, you learn, patience is a virtue.
Especially on this one, right after 9.5 years, right? What's a few more minutes to wait for something else
What's
to
a couple
happen?
of minutes?
Okay. I think we can go to mission operations right now, so let's take a look inside. On the Deep Space Network.
In lock on symbols.
So that's the first step. We're getting data.
Okay, copy that. We are in lock with telemetry with the spacecraft. Go ahead, CNDH.
CNDH reports nominal status. Our SSR pointers are where we expect them to be, which means we've recorded the expected amount of data.
Oh my God.
Copy that. Looks like we have a good data record. We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto.
That's it.
The spacecraft is in working order. The New Horizons team has gone where no other human being has gone before.
I would like to congratulate the New Horizons team and NASA on their pioneering, decade-long mission to explore the Pluto system and the Kuiper Belt. Billions of miles from Earth, this little robotic spacecraft will show us the first glimpse of mysterious Pluto at the very edge of our solar system.
Finally, the pictures begin to come in. We now see the planet in exquisite detail. Pluto becomes a known world.
Okay, so I'm not a geologist, but I am a rock climber, and I really like rocks, and I ski, and I really like skiing. So we're looking at the surface, and I look at the snow, and I'm looking for rocks. But actually, you look at those pictures, and they are just mind-boggling. They're totally cool. I mean, we were all jumping up and down, looking at them, wondering what's going on, and asking the geologists, what's happening here, what's happening there, and it looked remarkably like Mars. Much better than Mars, of course. It's infinitely better than Mars. But, well, it's kind of reddish. It's got impact craters. It's got cracks.
So first of all, we got high-resolution pictures of Pluto that we just showed off here today, the highest resolutions ever.
What about Buoy's maps? Did they guide New Horizons cameras to the best regions for scientific work? Buoy's map predicted the heart-shaped region now unofficially called Tombo Regio.
It is no accident that we are looking at that part of Pluto. All of the ground-based data that we've taken up to now, and all of the Hubble data told us, if you only can see one part of Pluto very, very accurately, which part would you want to see? And that's what we picked, is this region centered right on Tombaugh Regio.
High-resolution images taken by the LORRI camera reveal new landmarks. Here, along the edge of the Sputnik Planum, the autumn wind stirs a new chill across this vast, frozen plain. Mysterious polygonal mounds rule the landscape until they reach the ramparts of ancient, low-lying hills. It is a region now known as Sputnik Planum. Glaciers of nitrogen, ice, and slush ooze along the walls of a time-worn crater and spill into the planum, a process researchers are only just learning. Along the equator lies a sudden and inexplicable mountain range. Norgay Montes, a towering mountain of water ice some 11,000 feet tall, dark and brooding over its icy domain. The escarpments knife through the thin air, defying all attempts at erosion.
I think that's a case where our own intuition about geologic processes is failing us. This is so different that we need to learn about a whole new style of planetary landscape management, if you will, that other processes are working in different ways, and we have to look at all the clues that we're getting from the data. We've only been looking at these pictures for a few short hours, and we've got a lot of surprises that we're going to have to work through.
All I can say is it's wildly beautiful. The thing that I keep coming back to is that Pluto could have been boring. At least from my standpoint, there are certain objects in the solar system that are just sort of balls covered with craters, and Pluto is nothing like that, and Charon is nothing like that. We've hit the mother lode of fascinating objects in this particular mission.
Pluto's moons surprise everyone.
We have big news. From the first resolved image of Hydra, Pluto's outermost moon, to the discovery that Charon has been active. Thank you. Go ahead.
The first set of images released include this view of Pluto's outermost moon, Hydra. The shape of Hydra is not clear. Its bright white tonality is a mystery. Things in space get dark with age, and yet Hydra is very bright, which forces many to speculate Hydra is made of water ice. Many predicted Charon would be a crater-covered world, a fossil relic left over from the formation of the solar system.
And what we're finding is that it's still a fossil relic, but it's been painted over every week for the last 4 billion years. Maybe not every week, but every few thousand years we've got a new layer on top of it. And so what we're learning is a whole lot of very interesting geology. We're going to have to dig through that geology, not quite literally, but using our data to understand the composition and the core properties and so on. It is still a fossil relic, and we will still learn those properties of Pluto and Charon, but it's going to take a lot more work than we had maybe anticipated.
Of particular interest is the black splotch on Charon's North Pole.
The dark patch on the North Pole of Charon is definitely, it's a nice little Christmas present, if you will, a nice little surprise. Nobody predicted that. And we've already got a pretty nice explanation that's been talked about. It turns out that on the seasonal time scale, one pole of Charon most of the time is in intense, long-term darkness. And that dark pole cools down to extremely cold temperatures.
The dark hues are a thin residue of methane and ethane that survive the extreme cold. There's an enormous chasm on the side of Charon, and a sunken mountain, nearly 3 kilometers high. How did this happen? It turns out that both Pluto and Charon are not as dense and compacted as one might expect. The material in the bowl surrounding the mountain could have sagged from the weight of it.
The surface of Pluto is very, very complicated. What we see from remote observations is methane is the strongest signature, and nitrogen is the most by amount, even though its signature is very weak, and then we also see carbon monoxide.
Here we see a map generated from the spectroscopic readings of LISA. Purple shows the distribution of methane across the surface. The smooth Sputnik planum appears to have some of the highest concentrations of methane.
We know from the bulk composition of Pluto, from its density, that Pluto's got to have a lot of water ice. But spectroscopically, we can't see that. So that tells us, perhaps from remote observations, that the water is completely hidden from view. And that's certainly a big possibility.
24 hours after passing through the Pluto-Charon system, New Horizons is nearly 1 million miles behind the planet. The probe spins around and captures one of the most spectacular images of the mission, the backlit atmosphere of Pluto.
And you've got Pluto with its extended atmosphere, and it's losing stuff off the top of the atmosphere all the time. And there's some great models showing just how much gas there would be in and around Charon.
Pluto has one of the most unusual atmospheres in our solar system. It's a lot bigger than the rest of the planet, and it's leaking into space. As the spacecraft passes to the night side of Pluto, Alice looks back into the sunlight streaming through Pluto's atmosphere.
ALICE, which is an ultraviolet spectrometer, has the capability of looking back through Pluto's atmosphere as the spacecraft goes behind and look at ultraviolet light that's coming from the sun and being attenuated by the various gas species in the atmosphere. And so that'll be a great way of getting at the chemical compositions in the atmosphere.
Some speculate that the air was once more dense than it is today.
We know that Pluto's atmosphere has changed dramatically in the last 30 years. We've been measuring its atmospheric pressure from Earth by watching stars go behind Pluto, and the way that their light winks out tells us the atmospheric pressure. And it's doubled. In fact, it's more than doubled from the 80s to today. And that means that more material is in the atmosphere. And it's either been injected, for example, from volcanoes or geysers, or it's due to snows that have been vaporized and become part of the atmosphere. We don't know which. It could be a combination of both, in fact. And when we get the data sets for composition and temperature and topography and geology, we'll be able to put that whole story together from those clues.
And yet, even as the planet slips into the wake of history, data streams back to Earth.
The data that's going to come in from New Horizons, I mean, clearly there's a lot about geology, but we'll get maps. We'll be able to see where the light and dark patterns are, and I'll be able to compare that to the maps that I've done over the years. But first, I'm going to savor the up-close pictures.
By week 4 after the flyby, new images are downloaded. Earth gets a second detailed look at the strange geology of Pluto. Here, we see new detail in the border realm of the Sputnik planum. Strange blocks of water ice dominate the center of this image. The smallest objects are half a kilometer across. Are these dunes of granulized nitrogen shifting in the winds of a cold Plutonian sirocco? Or are they frozen in place like the sand dunes of Mars? Here, we fly down to the surface of Pluto, along the outer wall of a large crater. The darker ground on the left is the oldest surface. The older the ground, the more heavily cratered. The yellow crater floor is not as old as the darker surroundings. The white ground is fresh nitrogen snow. The moon, Charon, dominates the sky. But does it really snow on Pluto? Maybe not.
We've even seen, even at the very low resolution of our Earth-based and Hubble studies, evidence over the last couple of decades that Pluto's surface appearance is changing. And so we're pretty sure it's due to what we call volatile migration. or volatile transport, which means snow's moving. It's a fancy way of saying snow's moving. The computer models show that that's what should be happening. The data, although sketchy from the Earth, tells us that that's happening. And now we're going to go zooming right up on top of it where we can really get the details.
How did the mountains form? This image is some 75 miles across, and we can see details down to 270 meters. Lone mountains draped in streamers of red bunting form an unexpected archipelago in a sea of frozen nitrogen. The patterns resemble wind-whipped dunes.
So here we have these great pictures that were just released today that show these topographic features, these mountains that are huge by any measure, and you can't make that out of nitrogen or methane or carbon monoxide. The only building block that you have in Pluto that you can make these with is rock and ice. Now the rock we think is sequestered way deep in the core of Pluto, much like the Earth has got this iron core. But Pluto we think has a mantle that's made out of water ice.
Because water ice is less dense than nitrogen ice, we see here chunky hills of water ice pulled outward by invisible slow-moving currents in frozen seas of nitrogen, like icebergs. The force driving this convection is unknown. New data from LISA shows exposed water ice to be considerably more widespread across Pluto's surface than was previously known. This suggests that Pluto's icy bedrock is hidden beneath a thick blanket of other ices, such as methane, nitrogen, and carbon monoxide.
That's a real mystery. And I think that points to the fact that we don't understand these ice worlds.
But nothing is quite as startling as the color seen in this composite portrait. Blue, red, and infrared images recorded by Ralph resolve details as small as 0.8 of a mile. Image processing is used to coax more terrain from the region unofficially called Tartarus Dorsa, hidden in the twilight. We behold something totally new. Nothing like it exists anywhere else in our solar system. A phalanx of strange ridges bristling along the edge of night. This region more resembles the scales of a dragon or the bark of a tree than landforms. Are the ridges the result of tectonic forces generated by internal heat? Or are they the work of sublimation due to the light of a very remote sun?
We're going to have to go back and understand why that is. That these rocky and icy worlds stay wet longer than we ever imagined. It's hidden deep beneath, but there's definitely something strange going on there.
Are these wadis a record of ancient flash floods? Could these crater floors be covered by a fresh snow, an early sign of the onset of a dark Plutonian winter?
Pluto's far more active and diverse than even my imagination said it was going to be. That's okay, because, you know, every time we've gone to a new place, we always find our imaginations are never up to the task.
Some 7 weeks after the Pluto encounter, New Horizons will begin to relay tens of gigabits of stored data back to Earth. As the distance continues to grow, the downlink will diminish, with speeds falling from 2,000 bits per second to about 700 bits per second.
And even though we're using the very largest antennas on the ground that we have, the 70 meter, it will take 16 months for us to get that data back to Earth.
By 2017, New Horizons will be deep in a realm of far-flung chunks of ice. But what is this new region? Science now divides our solar system into 3 zones. The innermost planets, Mercury, Venus, Earth, and Mars, are small, rocky, and close to the Sun. This is the first zone. The second zone is the domain of gas giants, Jupiter and Saturn, Uranus and Neptune. Tiny Pluto marks the outer edge. Yet astronomer Gerhard Kuiper predicts the existence of a belt of icy bodies that lie beyond Neptune, girdling the entire solar system. A vast flattened plain of icy bodies now called the Kuiper Belt. New Horizons is now making its way toward its next target, the Kuiper Belt object designated as PT-1, a potato-shaped chunk 45 kilometers across, likely similar to the Plutonian moons Hydra or Styx. The rendezvous with PT-1 is set for January 2019. By then, New Horizons will be another billion miles from Pluto.
Another thing that we don't know about is a small end of the size population in the Kuiper Belt. And broken up little bits of Kuiper Belt objects are what come in to make comets, which are tiny, tiny little fragments of Kuiper Belt objects, a kilometer across instead of the 100-kilometer across.
Understanding the formation and evolution of our solar system has come a long way since the discovery of the Kuiper Belt.
We know there was a period of time in the first billion years, this was a dangerous place to be, anywhere in the solar system. One epoch in the past of our solar system, the giant planets are all moving around. They're actually plowing into the original Kuiper Belt. We're only seeing the remnants of the Kuiper Belt right now. And Jupiter, Saturn, Uranus, and Neptune probably plowed into that and scattered them all over the place.
These scattered bodies caused numerous collisions, most small, some large. And in the case of Pluto and one other planet in our solar system, there was a collision big enough to smash the entire world. That other planet is Earth. And from the scattered debris, our moon was formed. Astronomers call this period the Late Heavy Bombardment. The abundant craters across the face of the moon are a testament to the violence of this epoch.
We think that these large-scale collisions between planets early in the formation era of solar systems are common, and in computer models, we see that happens a lot.
Here we've got clues out in the Kuiper Belt that indicate that's what happened.
And the fact that we have more than one example in our own solar system is evidence that adds to what the computer models are telling us to say those models are probably right. It probably actually does happen a lot. So systems like Pluto-Charon or like the Earth-Moon may be common throughout the galaxy. That's one of the exciting things about going to the Pluto system, is that we're looking at something that, although it's far from our Earth, and far from our common experience, may actually be important in planetary science in other solar systems as well.
With so much success exploring Pluto and the Kuiper Belt, New Horizons is giving us an account of our own origins. And just what kind of gumption does it take to send a probe to Pluto, the Kuiper Belt, and new mysteries beyond?
It's the curiosity in me. It's uncovering the mysteries, things that we don't know. It's that continuing revelation.
Each time you see a planet for the first time ever, it's really amazing. There's just so many surprises, and you learn so much more because it was a distant point of light, and now suddenly it's a world that you have maps of, and you can count the craters, and you can see what's going on the surface.
Only one nation has, in the past 50 years, opened the entire solar system and is now probing the Kuiper Belt.
In that 50 years, the United States swept across the entirety of our solar system and was first to every planet in the solar system. And as a result of that, we not only made huge discoveries about nature and about the formation of our place in the universe, our home solar system, but we also made a great impression, I think, across the world for what our society and our country does.
Yet, for all the skeptics and cynics, New Horizons is the reply.
People often ask if we're as good as we used to be, if we're on our game, you know, if America is the same America that did things like Apollo. That New Horizons is an example, I think, of what we do best, making history, developing new knowledge, and doing it for all mankind.
Each week, new knowledge will be gained until all of the data is finished downloading in early 2017. Some 6 months since the encounter, the latest pictures reveal a world alive with bizarre forms of geology not known on Earth. Here, scientists think is one of the largest cryovolcanoes in our solar system. The Ralph camera reveals mysterious red splotches around the volcano. The region must be geologically active because only one lone impact crater can be seen. Their origin and nature unknown. The New Horizons project is a juggernaut of determination, patience, and planning, a fusion of engineering and science. And it is the ultimate expression of our curiosity, reaching into the high plains of the Kuiper Belt and into deep space beyond.